tell me, what is the refraction and deviation? What is the meaning of that? If I'm going to ask, what is a refraction? So what is your answer? Okay, when light travels from one medium to another medium, the light is bends. Okay, very good, very good, very good. What is the refractive index, friends? What is the refractive index? So of course your light travel from one medium to another medium. They bend towards the normal or away from the normal. This phenomenon is simply called as a refraction. Very good. Then okay. So okay, Dishadip. Okay, refraction. So now what is a this is a refraction. Now I'm going to ask what is a refractive index. So it's more critical angle to less refraction or reflection. The refractive index is a more critical angle and the less refraction or reflection. Okay, so question, no problem. So first of all, I ask a question, what is the refractive index? So can anyone tell me what is the meaning of refractive index? So your refractive index is a formula of speed of light in vacuum versus speed of light in a medium. Okay, am I right? This is a formula for refractive index, friends. Parikshit, please set your camera because you are not visible. Yeah. Now, when I'm going to say this refractive index imply that this is the speed of light, and this is imply the speed of light in a medium. So if your speed of light in a medium going to be decreased, because of course because of your medium is rigid, your speed of light is going to be decreased, so your velocity of light going to be changed, but this is a change is a very slightly. This is the reason behind it. Your always refractive index is greater than or equal to 1. Am I right? Clear? So if I'm going to say my refractive index, imagine if I'm going to say I have a refractive index is 1 and another refractive index I have 1.2. So this this is a rarer medium because the less refractive index as compared to this is a denser condition. Your refraction is going to be take place. So this is a light coming from rarer to denser. So your light bent towards the normal. Clear this? Because your light coming from rarer to denser. If same scenario, if I'm going to say my light coming from denser to rarer, so it takes reverse. So it is move away from the normal. Clear this, Sudarshan? This is your answer of your question. Sudarshan, please unmute yourself. Okay, no problem. So let's move. Today we are going to talk about optical instrument. So before the starting of optical instrument, the last question, what is a magnification? Can anyone tell me? What is the meaning of magnification, students? Image height by object height. Okay, very good. So it implies the image height by object height. Am I right? So it is for the lenses. Am I right? You are going to learn different kinds of lenses like a concave lens, convex lens, and you are going to see the image formation of that. Am I right? So now we are going to talk about optical instrument. So can anyone tell me what is the meaning of optical instrument, students? What is the meaning of optical instrument? No one? No one remember optical instrument? Best example, for example, your microscope, telescope. You are going to use to seeing a star purpose. You are going to use your telescope for seeing a small organism in a biology practicals or different kinds of practical. For example, like a magnification glass. At that time, we are going to use this magnification glass to see small things. Am I right? Like a small letter, anything. Am I right? So this kind of instrument, it is under your optical instrument. So let's talk about chromatic aberration. Okay. So what is meaning of aberration? What is the meaning of aberration? Please turn on your camera, students. Anyone have any idea about aberration? The instrument which used to magnify an object, very good. Like telescope, microscope, very good. Okay, now my question is aberration. What is the meaning of aberration? Any idea? No idea? Okay. Okay, no problem, Acha. Aberration is simply called as a defect. Okay. Now it is not the right question to ask what is the meaning of defect, because everybody know that what is the meaning of defect. So, bacha, if you don't know what is the meaning of defect, I'm going to explain this also. Just see. This is your lens. If your object present at infinity, where is your image is formed? If your object present at infinity, where is your image is formed, students? Anyone have any idea about that? Very good, Parikshit. It's a focus. Am I right? So I'm going to say this is my line. This is my principal axis. If my light is coming from infinity, this kind of things. So we know that it is simply passes from your focus point. So they all merge at the same points. Am I right? This is a scenario. So this is called as a focus point and perfect focus. So your focal length, but what happened when aberration is come? Why we are going to say it is an aberration? So just see, if your light, bacha, coming from infinity or anywhere, just see. They merge at a point like that. So they are not going to form a focus. Now they are spread like this. So this is your point. Understood what happened here? So instead of, because it is a convex lens, what is the working of convex lens? Convex lens do the converging part. Am I right? So it is converges your light. But because of your aberration is come, because of your lens, maybe lens is thick, maybe light is not so much proper. So because of your aberration, if light is not focused at a single point, they spread all over the system. So it is simply called as a aberration. Understood? What is the meaning of aberration? Understood? Everyone? Okay. Now my question. What is the meaning of chromatic? What is the meaning of chromatic, students? Related to color? Very good. Yes. Your chromatic is called as a related to your color. Okay. So if I'm going to say it is a single chromatic, that means single color. But we know that our light has a 7 colors. Am I right? So when light is coming, they have a 7 colors. So if I'm going to talk about this 7 color light, what happened? Just see. So if this is your white light, just imagine, my dear students, this is your white light. So if this color is coming because of this your lens, it is not separate their color. Am I right? So in which condition your white light separated their 7 segment of the color? So for that purpose, which type of lens we are going to use? Anything remember for that? Dispersion is going to be take place in a prism. Am I right? So if you want dispersion of light, so you need a prism. So if you know that we have a special type of your lenses which is also formed with a prism. So let's say I'm going to this lens, it is simply behave like a where your dispersion of light take place. Now in this scenario, I'm going to take this is okay. This is your violet, this is your white light is coming. Okay. So when your white light is coming, just imagine. Now this is a type of lens which is separate their 7 segment of color. So now this is your violet light and this is your red light. Okay. So they perform at focus, but At this focus, you get FV focus and you get here FR focus. Clear this? So what happened? You are not getting one proper focus point. Your focus now it's shifted with respect to their color. Okay. As we know that your refractive index of violet, your refractive index of your violet color is less than your refractive index of red color, or its opposite. It is right or wrong, students? Your refractive index of violet is greater than your refractive index of red, or your refractive index of red is greater than refractive index of violet. Which option, right? A or option B? No, don't know. No one. Your refractive index of violet is greater than the refractive index of red, or vice versa. Which option is correct? Option A or option B? Very good. So your option A is correct. Your refractive index of your violet is greater than the refractive index of red. So this is the reason behind it. You get first your FV, which is a focal point of violet, and then focal point of red. Clear this? So you get this. So for here, we need to define what is actually, why it is happened. Okay. So please remember, mu is a lens, mu is called as a refractive index. So your refractive index is always for violet is greater than minimum for red. So your refractive index is minimum for red and greater for violet. It is a very important question, because on that base we are going to solve a numericals. Okay. Now let's talk about what is our lens for a single. So if you remember your lens formula for the single, because as the medium is changes, it's something 1 upon f is equal to mu minus 1 by R1 minus 1 by R2. Clear this? So we are going to solve this equation. So we are going to write this equation for first red purpose and then violet purpose. So 1 upon FR is equal to mu R minus 1 divided by 1 upon R1 minus 1 upon R2. Then once again we are going to write for the violet purpose 1 upon FV is equal to mu V minus 1 divided by 1 upon R1 minus 1 upon R2. We are going to simply simultaneously solve this equation. After solving this equation, we get a final equation. Which is simply your FR minus, okay, I'm writing in, see, after solving this, you get something, a final equation, FR minus FV is equal to mu R minus mu V minus mu R by mu minus 1. Now, this is your final equation. Clear this? So this equation from here, we can say your mu R, mu V minus mu R by mu minus 1 is called as a omega F. So anyone remember what is the meaning of omega? Just give me 1 minute. Chair is some problem. What is the meaning of omega, my dear students? Yeah. What is the meaning of omega? Anyone remember the name omega here? Don't say angular velocity or angular frequency over here, because it is not related with your Newtonian mechanics. Anyone remember what is omega here? No one remember what is omega here, students? Anyone remember the omega here? So V by R. So we are going to take a V by R. Anyone remember what is omega here? No one? Okay, no problem. Your omega is called as a dispersive power. Now what is the meaning of this dispersive power? they are going to show that what is the distance, what is the difference between your violet light and red light. Because in that, instead of the spot, the perfect white spot, they give a one red spot and one purple, violet spot. In that, your Vibgyor is present. Am I right? So this is show something a longitudinal type of color band instead of showing a one spot at your focus. Understood? So this is show one type of error, one type of defect because of your lens. That means you are going to see, instead of proper color, you are going to see some blur part. Understood? You are going to see that if you are going to purchase, instead of purchasing iPhone, if you are going to purchase any Android phone, after some interval of time, you are going to see that Android phone camera changes. Their resolution is going to be changed. If you are going to focus, their focus is not as much proper as earlier one. Am I right? So why this is happened? Because their chromatic aberration is going to be shifted. There is some defect is occur on that. Understood? You see that your camera is going to be blur. When you are going to say that, ma'am, please, mom, please purchase a new phone because my camera is not working properly. Why it is happened? Because of their aberration is going to be changed. Understood, bacha? So this type of aberration is called as a chromatic aberration, and this is a under of your longitudinal aberration, because you are going to see difference between in this manner. That means a longitudinally. Understood? Clear this? So this is a very important. Please keep in mind. This is a dispersive power. So if we are going to solve this, so from here we get simply your Fv minus Fr is equal to omega F, and this is called as a dispersive power, and this term is defined as your longitudinal chromatic aberration. The longitudinal is also called as a axial. Clear up to here? Anyone have any doubt, any problem? Any part is not going to be understood by that? Just see, student, this numerical part between here, the derivation. Just give me a minute. This part, it's not mandatory. If you are going to solve simultaneously, you get this equation. This equation is important. After that, if this is V minus R, you are going to put mu V minus mu R. If it is R minus V, you are going to put mu R minus mu V. Understood? Only this is the difference. Clear this? So after solving this, you get simply this kind of called, and this is called as a, the omega is called as a dispersive power, and this term is called as a longitudinal chromatic aberration. Now just see in the diagram where is formed. Just see. In the diagram, this is your white light, this is your white light, this is your white light. The white light is merged at a point at a proper focus, but because their light is split, your dispersion is happened, they perform a chromatic aberration. At focus this, you get a violet light. At focus this, you get a red light. So in that, in between, you get your Vibgyor. Understood? So it is simply Fr minus Fv is equal to Wf. This Wf called as a dispersive power of the lens. Understood? Let's move further. Yeah. Now just see. The second one is called as a lateral chromatic aberration. What is the meaning of lateral? No idea? Okay. Just see. Lengthwise. Yeah, very good. So which length? It's possible to say which length? If you are going to see in your longitudinal, you are going to talk about longitudinally. That means the difference between the focus point, your focal length. Am I right? So similarly manner, when we are going to say lateral, you have heard the word kind of lateral displacement, if I am not wrong. You heard this lateral displacement? No? Are you sure? Okay, let's no problem. I'm going to draw the diagram. Then after you are saying yes, ma'am, we are doing this. Okay, just give me 1 minute. Yeah. Let's say I'm going to say this is my glass slab, and this is my normal. So, okay, before the glass slab, if I'm going to say this is my ray. So this is my ray. Am I right? Fine. So this is my ray. This is my ray. Now I'm going to place here a glass slab. So let's say this is my glass slab. So if there's a glass slab is present, so this is your angle of incident. Am I right? So this is your normal, my dear students. So what happened? If this is your angle of incident, what happened? Your light is going to be bent towards the normal because it's traveled from rarer medium to denser medium. Right? Your light is shifted towards the normal. So your light going to something like this, and this is your angle. So you are going to say this is your angle of incident, this is your angle of refraction. What happened? Once again, your light is traveled from glass to rarer medium, so it is going away from the away from the normal. So it is something like this, going away from the normal. Am I right? This kind of scenarios happen. Now tell me, students, what is your actual path of your light? Your actual path of light, this red one, but your light is travel this black one part. So what is this called? Between in this, what is called this part? No one remember? Yeah, lateral displacement, lateral shift. Am I right? So you are going to talk about what is a shift occur because of your glass slab. Am I right, bacha? So you also write, and if I'm not wrong, you are writing some equation x is equal to t times sine I minus r by cos r. This is your x and t is a thickness. Am I right? This is your equation of your lateral shift or lateral displacement. Similarly, here we are going to talk about lateral chromatic aberration. Of course, you are going to say lengthwise, height-wise, very good. That means in the previous, in longitudinal, we are going to talk about focal length, difference between a focal length. But now in lateral, we are going to talk about difference between your height. So now can anyone tell me which height? Which height? I want which height? What is lenses do simply? Object distance, object height. Are you getting? Not? That means if this is your object, if this object it's placed in front of your lens, it gives image height like this. Am I right? This is your image height. So now this gives the size of your red color and violet color, their image height. Understood? So they change. So here in lateral displacement, we are going to talk about image height. Easy? Clear this? Okay. It's a very easy. We're going to take an example of that. Just see. This is your lens, bacha. Now this is your just give me 2 minutes. I'm going to draw this diagram so you are easily understood what is actually, because this is a ready-made diagram, so maybe it's confused for you. So this is your lens. Now this is the principal axis. I'm going to take your object as here. Okay, this is, let's say, your object. So or should I use color black? This is your object, bacha. Okay, so what happened? If this is your object, your light pass, one light passes like this. So I'm going to say in this manner your light is passing. So one in, okay, one this and this. Okay, so this is your way of to represent your ray diagram. So one light is passing like this. So after that they are diffraction going to show. Similarly, one light is passing from the center of your, in this manner. Am I right, students? So one light is passing from this. So we are going to say they are passing from this at the focus of this. So this is your another. So this is your another light. Now what happened? When your light is reaches here, they are going to form a two. So of course they are going to perform a chromatic aberration. So they are going to separate out in a violet and red color. Am I right? So just see what happened. If your light is here, it's separate out in a violet color. This is your violet color. Okay, so these are separated in a violet color, and this is also separated in a violet color. Clear this? Similarly, if I'm going to say your light is a red color, so of course they are going to form a ray which is away from this. So this is your red color, and this light is your red color. Just give me 1 minute. I'm going to draw. Yeah, this is your red color. Okay, clear this? Now see. So at this point where your light is merging, this point, this point. So this is your height of your object. This is your height of your object. Am I right? This is your height of object because this is because of your violet light. Am I right? They meet, so their object form here. Now, similarly, if I'm going to talk about where is the height of your red color. So this is your red color. So your height of red color is somewhere here. Just see here. So this is your height of red color. Am I right? This is understood? Easy. What happened? Your two light is merging because they are going to separate out their 7 colors. So purple merge with purple, red merge with red. Your purple merging before some time, and your red merging after some time because of their refractive indexes. Am I right? We talk about we talk already to your refractive index mu. Sorry, I'm going to write here. Your refractive index mu r, mu v is greater than mu r. Am I right? So your purple form a less focal length as compared to your red. Now, what is your lateral shift, lateral aberration? So just see, students, this merging point, this line. If I'm going to bring this line here and this line here, so the difference between this is simply called as a lateral displacement or lateral aberration. That means we are going to say what is the height. So this is your height. Let's say I'm going to say this is your y, this yb, and this is the height is yr. So what is your lateral displacement? So your lateral displacement is something yr minus yb. This is called as a lateral aberration. Clear this? So this is your actual image height. So if you are going to see that your image height of this object for violet color, it's a less as compared to for your red color. Clear this? So here also you are going to see the shift of the light, which is because of your defect, which is called as a aberration. Understood? Kyle, Sudarshan, Pranav. Understood? Okay. So just see, this is your lateral aberration. So this is for because of violet light. This is for your violet light. This is for your red light. So difference between this distance is simply called as a lateral chromatic aberration. Okay. If you remember your magnification, so your magnification for the lenses, we are going to say f by f plus u. Clear? This is for a different color. If your light is produced different color, so we are going to use magnification image height versus object height instead of f by f plus u, or also we have a different f minus v by f also. Okay. So this is respect to your object distance. Clear this? Parikshit, understood? Hello Parikshit, understood? Okay, so please remember in your lateral chromatic aberration, they are going to talk about the distance difference between your object height, sorry, and your longitudinal chromatic aberration. They are going to talk about difference between your focal length. Easy? Clear this? This is all about your chromatic aberration. Okay, Let's, this is your, just see. So what you get, the chromatic, lateral chromatic aberration is equal to, what is our final answer? The lateral chromatic aberration is equal to height of red minus height of violet. Am I right? That means the distance of your total image distance of your red minus total image distance of your violet. It's give the lateral shift, lateral chromatic aberration. Easy? Okay, let's move further. So achromatism, what is the meaning of achromatism? So if we are going to say, if we are going to combine two or more than lenses, because in the day-to-day life you are going to see, just recently your Chandrayaan 3 is successful, am I right? So you get a pictures of your Chandrama, your moon. So beta, the name is itself is Chandrayaan, is Chandrama kind of. Okay, origin from your Chandrama. Okay, no problem. The moon. So you get a proper picture of your moon. How you are getting a proper picture of moon? Because of they are going to use a very high resolution of your lenses. Okay, so in that lenses there is not possible to attach only one and two lenses. The some kind of the instrument is used. There are more than 4, 5, 6, 10, 20 lenses are combined. Okay, so now we know that if there is a some defect are present in the lenses, if you are not nullify that defect, more lenses when you are connected, that effect will be increased, which is produce a error. Okay, so these things will be take care of when we are designing a lens, any instrument. Okay, for example, why you are going to wear a specs? Because your vision is not proper. Okay, but if specs is not corrected your vision, so you no need to wear that. Am I right? So for that purpose we need to take care of the chromatic aberration. Okay, just see. Okay, if two or more lenses are combined together in a such a way that their combination produce an image due to all color at the same point, then this combination is called as a achromatic combination of lenses. What is the meaning of achromatic? Like a chromatic is a color. So what is the meaning of achromatic? If your 7 color merge together, what happened? Which color you get? White light. Am I right? White color. So achromatic, that means your all color are merging at one point. That means this combination is not possible, or combination at one single point. So if this scenario is happened, so your white light is getting. So this condition is simply called as a achromatic aberration. So from here we can say your dispersive power W1 by W2 is equal to simply minus of F1 by F2. Why? Because your achromatic aberration, there is not separation of the color. And what is the dispersive power? Dispersive power gives the, what is the capacity of prism and lenses to produce their white light into their 7 segment of the different colors. Okay. So this is called as a dispersive power. So if it is achromatic, so no need of your dispersive power. So it becomes your simply dispersive power is nothing but your focal length of the lenses. Easy? Easy? Okay, let's ask one question. What is the lens formula? Pranav, am I audible for you? So please unmute yourself if it is possible, because you all are planned that you are not able to unmute. Okay, Pranav, please unmute yourself. And what is the mirror formula? What is the mirror formula? Very good. Very good. Very good. Excellent, students. Inner lenses, these are minus. In the mirror, they are plus. So if you know that, so I consider you also know that which lens is converging, which lens is diverging, which mirror is converging, which mirror is diverging. So anyone here, it is possible to unmute and tell me instead of writing in chat box which lens is converging, which lens is a diverging. Anyone want to interested? Say the answer verbally. No one? I trust you guys. Your voice is very good. I know that. No one? Parikshit, will you try? Please unmute yourself, Parikshit.
Ma'am, in mirrors, convex mirror is diverging mirror, concave mirror is converging mirror.
Very good.
In lens, concave mirror is diverging, convex is converging.
Very good. Very good. Excellent. This is very easy, man. Instead of writing this all the thing, just unmute yourself and say that. If it is wrong, I'm not going to punish you because it's not possible. And if it is right, also it is not possible to reward you. Okay. Okay, let's move further. So now we are going to talk about simple microscope. So what is the working of your simple microscope? No one? What is a microscope? Why you are going to use a microscope? It is enlarged small object. Very good. It is a thing which is magnifying in microorganism. Yeah, exactly. Very good. Very good. Optical instrument purpose. Very good. Excellent, students. Yeah. So we have a microscopes. In that microscope, we are going to use two types of microscope mostly. First is called as a simple microscope and the second one is called as a compound microscope. So students, when we are going to use a compound microscope, is simply two lenses are combined. In the day-to-day life, we are going to use such kind of microscope. There is a 10, 15 lenses are combined, but in your syllabus only we are going to talk about a single or two lenses. Okay. So first we are going to talk about what is simply they do. So your microscope do simply converge because your microscope, simple microscope is simply called as a convex lens. So what is the working of your convex lens? Convex lens is converges your light. Am I right? Okay. What is your normal distinct vision for a normal human eye? Anyone know that? For normal human eye, what is your distinct vision? What is the distance of distinct vision? Very good. It's a 25 centimeter. Okay. So when we are going to talk about your simple microscope, first we are going to talk about where is your, so students, please remember, if you know that we are going to talk in a convex lenses, concave lenses, always we are going to talk about your magnification in terms of your object distance, image distance. Am I right? Or we can say object height or image height. But now, please tell me, it is possible when we are going to see something by our eye with your image distance and object distance? What you are learning in a concave and convex lens? In the concave and convex lens, they are going to say your magnification, your focal length, all are depend your object height or image height. Am I right? That means if your object this and you are going to see image is this, it's a magnified. Am I right? Similarly, if I'm going to say your object this and your image is this, it is a demagnified. We can say it is a diminished image. Am I right? But now, when we are going to see our normal eye, human eye, what is our? We are going to say that this is object height or image height. Our object will be changes as per our seeing purpose. No, it is not depend on the what is the angle by we are going to see. For example, if this is a pen kept away from me, like this is visible, this, it is normal for me. But if this is towards my eye, its height will be enlarges. Are you getting my point? So when I'm going to use a microscope, it is it's not depend on what is your actual height of your object. Now it is depend on at what distance you are going to see that object. Are you getting my point? What I'm trying to say? Understood? Sudarshan, Pranav. Okay, so just see. So please remember. So let's talk about first our. So it's called as a visual angle. What is a visual angle? Visual angle is simply defined as you in which angle we are going to see that object. Okay. So let's say this is our principal axis. Here your eye is present. Okay. So I'm going to consider this is your eye. This is your eye, bacha. And here some object is present. Okay. So what is your angle formed by that object is simply called as a visual angle. Okay. Clear this? So this angle is called as a alpha, or you can say a theta also. So this is simply, what is the meaning of visual angle? Is simply angle formed by object I. Clear this? Clear this? Now just see if your object present here. Just see. If I'm going to say my object present here, same as height is the same. Just see my object present here. Same height. I'm not going to change the height of your object. What happened? Your angle is something like that. Am I right? Just see. What is your angle? Now this angle is much greater than the previous angle. Understand? Understood what I'm going to try to say? In all condition, you are always talking about magnification, something height of object, image of object. Are you getting? But now it is not depend on what is your actual height and what is height is appears. It is depend at what distance you are going to see that. Getting? So if your object is very close to you, your angle will be very greater. If your object very away from you, your angle will be very small. On that basis, we are going to say our object is small or big. Understood? So this is your visual angle. So from here, we can say simply, we can say that your height of object is directly proportional to visual angle. Understood up to here? All of you? Clear, Pranav, Sudarshan, Kyle? Okay, let's. Okay, now we are going to talk about your micro magnification power. So what is your magnification? So just see, magnification of your microscopes is defined as, just write down this equation is very important. Your magnification for any type of microscope is defined as visual angle formed by final object divided by visual angle formed by object which is kept at D. What is D? D is called as normal distinct vision. So this distance from here to here, it's simply called as a D. Clear this? Everyone? Parikshit, understood? Okay, let's move further. So this is your magnification power definition. So this is your magnification definition. What is the definition of magnification? Visual angle formed by a final object. So this is, I don't know what is this, but I'm kept at distance D. So now what is this? So I'm just writing here. So this denominator part, I know that it is simply alpha, but what is the numerator part? It's a beta. I'm going to explain this beta from where your beta is introduced. Plus till just up to here only. This is your beta. Clear this? So let's talk about your microscope. Okay, so simple microscope. So what is the diagram of your simple microscope? So let's move further. Your simple microscope. So your simple microscope, bacha, similarly behave as a convex lens. Best example, you are going to see your magnifying lenses, which is magnify your image. Am I right? So now my question is, you know that there's a different condition where is our object present, so where we get a image for a convex lens. You know that conditions? Let's check. If it is your light is coming from infinity, your image is appear at focus. So similarly, if I'm going to say my object present at focus, so my image will be formed at a infinity. Okay. If my object present at your center of curvature, where is your image is formed? If my object present at center of curvature, where is your image will be formed, bacha? No one remember? If your object is center of curvature, your image also form at the center of curvature, but it is real and inverted. Am I right? So similarly, if your object present between focus and optical center. Okay. So for that simple microscope purpose, we are going to use a convex lens, and the condition is your object present at focus and center of optical center. Optical. Easy. So let's draw this diagram. Once again, we are going to use two lenses. Just see. Okay. This is your lens, bacha. I know your lens is big, but we are going to consider this only. Okay. Now we are going to say our object present focus and optical center. Where is your optical center, bacha? Your optical center is somewhere here, and your focus is somewhere here. So I'm going to say your object present here. Okay. So if this is your object, so we are going to draw the diagram. So what is your diagram? First, your rays passing like this, and the second ray is passing from your optical center. And the ray after passing here, they bend something like this. And what happened? Your light ray is never meeting, because if your, am I right now? This ray is not possible to meet. So here we can say our this point is simply a diverging rays which never meets. Am I right, bacha? So if your eye present over here, if you are going to see here, you are going to see there is light is. Now we are going to present our eye here. Just see. I'm going to try to draw proper eye. Okay, this is your eye. Just imagine. So if your eye is present here, so your image somewhere form here. Am I right? Let's draw the diagram. So if I'm going to increase this light like this, and if I'm going to increase this light is like this, what happened? They are going to merge at a point. This point is simply called as your, this point is simply called this, and if it is A and B, it is A dash and B dash. Clear this? Clear this? So this A dash and B dash is your, what is this A dash and B dash, bacha? Can anyone tell me? This is your final image. Clear this? Easy? Your A point here, so from here to here distance is called as a U. Now this lens is called as a I lens. So I'm going to write UE. Easy up to here? Easy, all of you? Now they are going to say angle. So what is your beta? So here I'm going to say is the angle is something where we are going to see visual angle. So what is your beta, bacha? So this angle called is your angle of beta. Easy? Clear this? Okay. So what is our image? This is our image. So I want this line with respect to this. So for that purpose, we are going to say, just see, we are going to say tan beta is equal to, what is beta angle? Beta angle is called as a opposite upon adjacent. Am I right? So what is your opposite? Is your this this is opposite AB, and what is your adjacent? It is mu E. Easy? Clear this? Hello students, clear this? Okay. So we know that if our object, because if I want magnification, so I'm not going to use a 2 centimeter long, 2 meter long object for magnifying purpose. It is normally visible. Am I right? So I'm going to use a small object. So we can say our beta is small. So if I'm going to say my beta is, my angle is very small. So from here, your tan beta is approximately equal to beta. So from here we get, what is your beta bacha? Beta will be AB. What is your AB? This is the height of object. This height of object divided by mu E, object distance. Easy? Clear this? So this is your angle beta. Okay, now once again, what is your angle of alpha? No need to find angle of alpha with the help of your microscope. Angle of alpha, it is for your normal human distinct vision, and which is defined as alpha is equal to, what is your alpha here? Alpha is, once again, it is divided by D. Am I right? Now, just see. Your alpha defined as, it is a visual angle, and it is defined at your object height, object where is present, if you are going to see by your normal human distinct vision. So what is the distance of normal human distinct vision? It's something this. This is your object, and this is your angle is formed. So here your eye is present. Okay. So this is your alpha. This is your D. And this is your normal H naught. So from here we can say your alpha will be H naught by D. Clear this up to here? What is your alpha and beta? I repeat once again, your alpha is not related with microscope. Your alpha, this is your value of alpha is for everywhere. Normal distinct vision. Okay. Okay. So now we are going to talk about what is our magnification. So from here, our magnification M will be beta by alpha. So from here we get H naught by mu E divided by H naught by D. Your H naught get cancelled. So we get your magnification M will be D by mu E. Clear this? So what define, what is the magnification of your simple microscope? Simple microscope magnification defines at what is your distinct vision and where is your object is present. You are going to see, if you are going to take your normal magnifying glass, if you change your distance of vision, you are changing the size of your magnification. Am I right? Why this has happened? Because this is that factor. Clear this up to here, bacha, all of you? Or it is bounced from your mind? Parikshit, Pranav, Sudarshan, understood or not? Parikshit, understand? Yeah, bacha. Let's move further. This is your normal condition. Let's talk about your, so we get the formula. What is our formula? Your magnification M will be visual angle within the instrument, that means beta, and your maximum visual angle by the unaided eye, that means your normal distinct eye, which is called as a alpha. So beta by alpha. So we get a magnification power is H naught by this D by U. Why we are going to take a minus D? Because both are going to measure a sign convention. So both are as a your left hand side. So your D and mu both has a minus sign. Minus minus get cancelled. You get simply D by mu E. Understood? Okay. So now let's talk about the cases. So we are going to talk about the two cases. The case 1 is called when your image is produced at infinity. So now student, tell me, when your image is produced at infinity and why? What is the condition to present your form your image at infinity? And when your image is present at infinity, your magnification is maximum or minimum? Let's start from here. Tell me, if I'm going to say my image is produced at infinity, so my magnification is maximum or minimum? Maximum. Why, bacha? Okay, now tell me, if I'm going to say my image is within my range, or my image is at infinity. So if my image is present at infinity, my eyes is very relaxed. I'm seeing normal eyes. Yeah, it is visible. But if it is a within range, I'm going to strain on my eye. Am I right? Am I right? So when I'm going to say my image is infinity, that means we can say for normal adjustment, that means my eye here, your eye is relaxing. Your eye is relaxed. Normally we are going to see, we have a lots of distance to see that. Okay, no worry about. So we can say that means our final image at infinity. Easy? Clear? So what is our condition? So once again, our U is equal to, take a conditions, our UE is equal to, or we can say image distance. So image is, object is UE, and your image will be at infinity. So what is your focal length? Just see. Your focal length of lens is 1 by V minus 1 by U. So from here you get 1 by infinity minus 1 by mu E. It becomes 1 by mu E. Am I right, bacha? Clear this? So from here we can say our focal is equal to mu E. Clear? So what is your magnification? Just see. Your magnification M is equal to D by mu E. So we can say our magnification is equal to D by focus. Clear this? Now it is maximum or minimum, I don't know. Okay, so let's talk about the second condition. Okay, so this is for your image at infinity. So this is for your case 1. Let's talk about your case 2. I'm going to talk about your case 2. So what is case of our case 2? So we are going to take so if I'm going to say I'm seeing a very normal my eye. So what is our final image? So our final image is formed at D. Okay, normal distinct vision. So if my final image is formed at D, your U object distance will be minus U, your image distance will be minus D. So let's apply your mirror lens formula. 1 upon F is equal to 1 by V minus 1 by U. So from here we get 1 by minus D plus, minus of 1 by minus U. So if you are going to, you get simply 1 by UE is equal to 1 by F plus 1 by D. Clear up to here? This statement clear? Okay, just see. What is your magnification? So magnification is equal to D by mu E. So from here we can say it is something D by 1 upon F plus 1 by D. Okay. If you are going to open the bracket, what happened? It become D by F plus D by D. Easy? So from here we can see our magnification M will be 1 plus D by F. Now compare this magnification with this. Let's say I'm going to say this is my magnification of second case. This is my magnification of first case. So when your image is infinity, your magnification is simply D by F. But when your image at distinct vision, okay, distinct vision, that means 25 or more than, that we are easily measure where is our object image is present. So at that time your magnification is maximum. Clear this? So we can say this magnification is maximum and this magnification is minimum. Easy? Understood? Understood or not, students? Just say that. If it is not, I'm going to repeat, no problem. Clear this? So we can say for simple microscope, I'm going to write here. For simple microscope, your magnification M lies between 1 plus d by f to d by f. Clear this? All of you clear up to here? Any doubt in any diagram, diagrammatical representation? Just see the diagram also. Diagram is in the previous. Okay, just see. This is a diagram which drawn by us and the, sorry. This is your actual diagram. See what happened? Here your object is present. We are going to see here. So this is a diverging part. This is not meeting. So if I'm going to put here, so you get here. Now just tell me what is the characteristics of your image? Can anyone tell me? What is the characteristics of your image? No one remember? So please remember, if you remember your convex lens characteristics, so if your object present between focus and object, optical center, your image will be formed virtual, erect and magnified. No? Or erect, that means the same side. Okay. So if your object is present here, convex lens, so your object is present here. So your image, so what is your image characteristic? Your image characteristic is, okay, just see, I'm going to writing here. Your image characteristic is virtual, erect and magnified. When your object, where is your object? Focus and optical center. This is for your convex lens. Clear this, all of you? Okay, let's move further. So this is your formula. So if it is a within your distinct vision, its value is 1 plus df, and if it is your image produced at a infinite, that is a very far distance. So your magnification is d by f. Just see, this is your 1 plus df when your image is minimum distance or your clear vision, which is a d. Clear this, all of you? Understood or not? Understand? Let's move further. So this is the first type of your microscope, which is a simple microscope. Let's talk about a compound microscope. Okay, so before we are going to start your compound microscope, you want a break or should we continue? Expression देखो चेहरे पर, खुशी, लड़कों के चेहरे पे खुशी देखो, हाँ सब खुश हो गए. Okay, no problem. See your happiness when I'm going to say break. Yes, ma'am. You should wait for that. Okay, but you should come back na on time. Okay, so let's start sharp 8:25. Okay, let's take a break, then we will continue. Hello, friends. Okay, let's start the session. Hello. Start the session. Parikshit, Darshan. Okay, so now we're going to talk about a compound microscope. So what is the magnification for simple microscope? It is d by mu e. If it is your image is appear at a distinct vision, it becomes 1 plus d by your f. And if it is your image appears at a infinity, so we can say our magnification will be 1, not 1, it's a d by f only. Okay. Let's talk about compound microscope. So, bacha, in that compound microscope, we are going to use, this is used for a more magnification, because simple microscope, it's not going to use very high magnification, but your compound microscope gives a very more magnification as compared to a simple microscope. So, in that, we are going to use two lenses. One is called as a objective lens and another one is called as a eyepiece. I repeat once again, your objective lens and your compound microscope, it's a very easy. The second lens, it is behave like a simple microscope scenario. Thus, only one extra lens are present, which is called as a objective lens. Okay. So, let's see. So, this is a diagram of your simple compound microscope. Very simple. Okay. So, it seems to very difficult. I know that, but it's very simple. So, don't worry. I'm draw this diagram once again. So, you are very comfortable. Okay. So I'm going to use, this is our, okay. Now let's start with here. I'm going to use a small lens. This is your lens. Okay. Now this is your object. So what happened when your object present here? Not on, this color is not visible. Okay, just see this color is visible or not. So let's say this is your object. Am I right? Your object is present here. Now I'm going to say this is, so where how your image will be to form? You are going to produce one here and another here from the center of curvature, not center of curvature, optical center here. And this is your first ray, this is your second ray. So after passing this ray from here, it is also bent towards the focus. So it's passed from the focus and they meet this point. Am I right? Clear this? If it is passed from the focus, they are going to be meet. So let's at here this is your image A to B. So here your image is going to be formed. This is your image from A to A dash to B. Now see, as compared to this image is quite enlarged. Am I right? Clear this? Now imagine from here to similar your simple microscope. So I'm going to say this first object, this is simply called as a objective lens. Okay, which have a very small focal length, small focus. Okay, now let's consider a big lens. So this is your eyepiece lens. Okay, now what happened? Your ray is coming from here. So let's start with this. So first ray is, this is your object now. When it beta is, this is the object, your one ray is going like this, and your another ray is going from your center of your object, from this kind of, okay. So one ray is going from here, the center of object, another ray here. So this is diagram is so quite, okay, just no problem. I'm try to draw this diagram. Okay, I'm going to put here. This is your eye lens. Now, one ray is passed from here, and the other ray is passing from the center of your optical center. So another ray passing from your optical center like this. Okay, this is the rays passing from your optical center, and this ray is passing after this. It's passing something like this. Just see the focus point of this. So somewhere here. Okay, this have a very big focus. So the focus is somewhere here. Okay, just see. This is your focus beta. Now this is have a very. This is called as your eyepiece or eye lens. Instead of saying eyepiece, I'm going to say it's called as your eye lens, and they have a large focus. Okay, so here it is a diverging. This is a diverging ray. So in this, your rays not meet. So now your eye will be present over here. Okay, your eye is present here. So you are going to see. So what happened? Just see. When you are going to see, just see. I'm going to take this ray like this. Okay, red color. One ray from here, which is from your optical center, and the another ray from here, which is from your just see from here. So they are going to meet somewhere. So let's one ray from here and the red ray from here. So they are going to meet here. And if I'm going to draw the diagram, my final, I'm going to carry this line ahead. So what is my final image? My final image is this, the joining of these two. This is clear this. So this diagram is simply called as A double dash B double dash. Actually your direction of this, then this, and this. But your eye is present, so you are going to see your virtual image here. Where object is present here, your image is also same side. It's called as a virtual, erect, and magnified. Clear this? So it seems to so difficult, but diagram it's not so much difficult. They are similar to the previous one. Just see. So this is your actual diagram. Clear this? Clear this, bacha? Now we are going to talk about this diagram on the basis of the naming. Okay, so let's take some names of this. So this is your actual u distance, v distance, sorry, from here to this point. It is your v. What is your this? This is your u naught, which is called as object. Now what is your object from here? This is for ue. Clear this? Okay, now where is your alpha angle? Can anyone tell me where is your alpha angle is present? So your alpha, it's not for related to your microscope, your alpha for everywhere, it's a visual angle. So now here beta is present. So this is your angle of beta. This is your angle of beta. Clear this? Once again, what is your tan beta, bacha? So tan beta is equal to, what is your tan beta? Is A dash B dash by mu E. Your angle is very small, so we can say your beta is very small. So if your beta is very small, we can say, just see, tan beta is approximately equal to beta. So from here we can say beta is equal to A dash B dash by mu E. So we need to find what is your A dash. Clear this up to here? your beta is very small, so your tan beta is approximately equal to beta. Clear this, Darshan, Sudarshan, Pranav, Pranav, are you there or not? Okay, so let's move further. So we are going to find first your alpha. And what is your tan alpha? So tan alpha is once again here, this angle is called as a tan alpha. So it's H naught by D. Easy. So let's talk about your, first we are going to talk about your A dash and B dash. Okay, beta. So from where we get a dash and B dash. So if you remember, what is a magnification power? What is your magnification power? Anyone? You remember the definition of magnification power? From here to, what is the definition of your magnification power, students? This is your VE. Okay. Someone, what is the magnification power? What is the magnification for normal lens? What is the magnification for normal lens? Your magnification. Very good. Magnification for lens. Sudarshan, if you remember, if we are going to change our object distance, according to that, your image size is going to be changed. Okay. So in that manner, we can say our lens is also magnified. No problem. If you're going to ask a question, don't worry. Your mind is working. No problem, bacha. Okay. Clear this? Sudarshan, clear this? Okay. No problem. Okay, so magnification for lens. So what is the magnification of lens? M is equal to, we can say, image height, like that, image height by object height, or we can say image distance by object distance. Am I right? Clear this? But it is your object distance taken as a negative for your lenses. So from here, we can say our magnification for objective lens. This lens is called as object, the first lens. This lens is called as objective lens. So your magnification for your objective lens M naught will be V naught by U naught. What is V naught? It's something we are going to, this is your V naught. From here to here, this is your V naught. So what is your V naught is A dash and B dash, and what is your U naught? Your U naught is AB. Clear this? So if I'm going to equate this two equation, just see. If I'm going to equate this two equations, so from here we can say your V naught by mu naught is equal to A dash B dash by AB. So if I'm going to solve this, so from there we get your A dash B dash is equal to your A dash and B dash. Just see from the diagram, your A dash and B dash is a denominator side. That means this is a height. This is a height. So it's a negative, according to your sign convention. So this is a negative. So this negative and positive get cancelled. This negative and positive get cancelled. So we get your A dash B dash is equal to V naught by mu naught times AB. Clear this? And what is your AB? So according to this diagram, your AB is this, and which is called as a height of your object. Clear this? So we can say your A dash B dash is equal to H naught times V naught by mu naught. Okay. Now let's see what is your tan beta here. So from here we can say our beta is equal to A dash B dash by mu E. So it becomes H naught V naught by mu naught times mu E. Clear this up to here, beta? All of you? Okay. So you get a tan beta, which is, so I'm writing here, your beta is equal to H naught V naught by U naught UE, and your alpha is equal to H naught by D. So once again, what is your magnification? Your magnification is equal to beta by alpha. It's H naught V naught mu E into your, not into, it's a divide by h naught by d. So from here we can say your h naught get cancelled. Am I right? So you get something. Your magnification m will be v naught time d by mu naught time mu e. If you are going to see properly, just see bacha, it's become something v naught by mu naught into d by mu e. What is d by mu e? What is d by mu e? What is d by mu e, bacha? It is a magnification power for simple microscope where only one eyepiece is present. Am I right? Am I right? So from here we can say, we know that your ME, that means D by mu E, and we can say your M naught is V naught by, this is for objective lens, this is for eyepiece, mu naught. So from here we can say our magnification M will be magnification of objective lens into magnification of your eyepiece. Clear this? Parishit, any doubt? Understood? Pranav, all of you. Sudarshan, understood? Darshan. Okay. So just see the diagram. So this is your diagram, and in that, this is maybe if it is appear here, if it is appear here, this is your distance. If it is appear here, the distance will be increases. Okay? No problem apart. Clear this, bacha? It is defined as how many times it's magnified or not. So just see what is your magnification. Its magnification is mu naught time, sorry, mu naught, m naught time me, m naught for your objective lens and or me for your eyepiece lens. This is your objective lens, the first one. This one is your objective lens, this is your eyepiece lens. Clear this? Up to here. So this is a magnification of compound microscope. In that compound microscope, we are going to use only two. We are going to use only two lenses. We have that types of microscope where we are going to use lots of lenses. Okay. So according to that, your magnification is increases. Take an example. If your simple microscope has a magnification 2, okay, and this compound microscope, one lens has a magnification 2. So 2 into 2 become 4 now. Am I right? So as the previous simple microscope, this microscope has a more magnification. Understood? So you can, for example, your iPhone, if you are going to zoom, your picture is not going to be blur. Am I right? But in a normal, our type of, not our, you all have an iPhone kind of. But if somebody's have an Android phone, if you are going to zoom in, their zoom in is not going to be proper. Am I right? Their image is going to be blur, or sometimes image is not appear. Understood? Why this has happened? Because of their magnification power. Clear this? Okay, let's move further. So when your image, once again, it is created at the least distance. What's the meaning of least distance? So I'm going to say my formula is M magnification of compound microscope is magnification of object into magnification of your eyepiece. So if I'm going to say my final image at least vision, that means D distance. So my final image at D, if it is like that, at D. So what is your magnification? So your magnification of simple microscope becomes 1 plus D by F, because at your point D, it's a maximum. Am I right, bacha? So it's become 1 plus D. So if you are going to put in a formula, so you get the formula as something, this formula is becomes mu naught by mu E is equal to 1 plus D by Fe. Okay. Once again, what is your mu naught and U? If you remember, you can write this mu naught V naught is also we can write as your M naught is equal to F naught by F naught plus mu. This is a magnification of your objective lens, which is convex lens. So if you are going to equate this two in this equation, it become F naught by F naught plus mu naught into 1 plus D by Fe. If you are going to solve this, so after solving this, you simply get your magnification at for distinct vision is something H1 by H is 1 plus D by DE. What is your h1 by h? So your h1 is your height of your image when this form the first, which is behave as an object for the second eyepiece. Clear this? That means, just see here. This is one h1, this is your h2. So this is your object which is behave as a object for the second. So this one. Clear this? Clear this? So we are going to say h1 by h. That means the object which is behave as a the image which is behave as an object for the your eyepiece divided by your height of your object. If you are not understanding, just write your HP, the height of your object, and your h1 is a image of the objective lens, image of objective lens which used as object for eyepiece lens. Is it up to here, all of you? And the last question, last formula is length of the tube or length of your lens is becomes the total length of this is L is equal to V naught plus mu naught. We can say mu A. Clear up to here? Understood or not? Not understood? Sudarshan, should I repeat some part? Pranav? Okay, so let's move further. This is for compound microscope where your image is created at infinity. So after creating infinity, you get once again the d by f. So from here, we can say that, just see, from here we can say that our image formula, our image, the magnification is something m is equal to m naught time me, which we can write as m is equal to v naught by mu naught into d time mu e. Okay, so if it is for normal vision, okay, so normal vision, that means maximum. So for maximum vision, we are going to say your normal vision. So it's your strained eye, or we can say image at D. Okay, so for this condition, your magnification m will be something v naught by mu naught time 1 plus d by f. Okay, and if it is infinite, that means we can say minimum. Minimum, that means we can say relaxed eye, or we can say your image at infinity. So in this system, your magnification m will be v naught. The magnification m will be v naught by mu naught in time d by fe. Easy. This is a two condition for the compound microscope as the simple microscope. Clear this? If I'm going to say it is a strain eye, that means our image formed within a D point. If we are going to say it's a relaxed eye, that means a normal adjustment. So this is also called as a normal adjustment. Our image form at a infinity. Clear up to here, all of you? And the length of your microscope will be L naught plus mu e, or for that L naught plus V naught plus Fe. Understood up to here, all of you? Let's move further. Now we are going to talk about this is a compound microscope. So if we are going to take a condition, just see your value is given, bacha. Your power, magnification power is 30, your distance is 25, and your FE value is 5. So from here we can say minus 30 m plus. So now they are going to say your magnification power is given minus 30, distance of 25 is given, FE is 5 centimeter is given. So just see, our formula is magnification power is m naught time me. So m naught is m, given m naught is I don't know, so just find 1 plus df. For normal vision it's a formula. So from here we can say 30 m naught time 1 plus d will be 25, f will be 5, so it's become m naught time 1 plus 5. So we can say your m naught is minus 5, because becomes 6, or 6 divided by 30 is minus 5. Clear this? So negative sign indicate that your image is inverted. Clear this? So this is your magnification of your this, and if I'm going to multiply this here, so from here we can say this is 30, this is 6. So your magnification of your object eyepiece lens is a 6. Clear this? Understood? So this kind of your questions. Now we are going to talk about astronomical telescope. Okay. So in the telescope, your image is not going to be formed. Turn on your camera, students. In the telescope, your image is not going to be formed. Your image is, your object is not going to be, we are going to consider our object at infinity, or our image is going to form a within a range. Okay. So let's see. So in that we are going to use our objective lens, which is a very big, where we are going to consider our object is coming and our eyepiece is toward the earth. So just see, it's a very easy. This is your objective lens. So this is light, this ray show that your light is coming from here. Okay. That means your object presents somewhere infinity. All our approaches we get a simple point, and this ray is passing through your eyepiece and your eye is going to be present, which is simply called as a diverging. And it is also a diverging because your light is not as a single point, it's coming from very far infinite point. So you get an image in this region. Clear this? Please remember, in your telescope your object is not a single ray and it is travel from infinite distance. Okay. So this is your ray diagram. This is your eyepiece. Because your object, we are not going to say mu naught because it is present at your infinity. Object is present at your infinity. Yes. So once again, what is your formula of your telescope? So one is called as a beta by alpha. What is your beta? So just see, beta is your h dash height. So what is your h dash height? So your h dash is simply the height where your object is appears, but now your object is present at infinity. So when I'm going to pass my object from first my lens, which is called as the objective lens, I get a image. So this image is called as your, just see, oh, I'm going to use a pointer. This image is called as your object image. Clear? Which object is not formed, but their image is formed very small. So this image is called as your object image. So from here we can say your beta, just see, I'm going to write beta is equal to h dash by fe. Okay. Sorry, it's a mu e, this distance, because this is a beta angle, beta. Just see, here is a beta angle is present. This is a beta angle. So this height by this distance. So this height is called as h dash. This distance is called as mu e. Okay. And what is your alpha? Once again, your alpha is equal to d by mu e. Sorry. What is your alpha? What is your alpha? Once again, forget. What is your alpha, students? Alpha always h naught by d. Am I right? So your alpha is h naught by d. This is your h naught. So here we are not going to use directly h naught. So I'm going to say h dash once again, because your object height is not present. So we are going to take this height as a object height now. So once again it becomes h dash by d. So just see. So from here we can say your beta is h dash. Your beta is h dash by mu e. This is a minus because the present is left hand side. H dash by f naught. Your h dash get cancelled. So it becomes something h naught by mu e. Clear this? So this is your magnification power for telescope. Now just see, in the magnification of power, your telescope is independent of where is your object is present. They are going to talk about where is your object or image form in your eyepiece and your focal length of your system. Okay. So see, if your final image is present at your infinity, so we can say our VF is a infinity, mu is equal to VE. So after solving this, you simply get your VE is equal to FE, which is this formula. So you can write also magnification is equal to minus F naught by FE. So your magnification is F naught by FE. It's implied that when your image is from infinity. So it is simply depend on the focal length of your eyepiece and focal length of your eye lenses, because it is impossible to measure the distance from your telescope to stars. Am I right? Because this is the use of your telescope. Clear? And what is your length of this? So your length of the tube will be F naught plus Fe. So in the telescope, we are going to try to replace our all image object distance with their focal lengths. Clear this, bacha? Up to here, all of you. Pranav, understood? Sudarshan, Parikshit. Okay, let's move further. So this is for if your image is a distinct vision. So if it is a distinct vision, that means it is within our range. So at that time, our F naught and Fe becomes mu E. So we can say our magnification M will be minus of F naught by mu E. Or we can also say F naught by Fe time 1 plus Fe by D. So this is also possible for your distinct vision, which are within the range of 25 centimeter. Okay, clear this? And what is your length? Length is F naught plus mu E. All of you clear this up to here? Okay, let's move further. Now this is a very special type of your telescope. In that telescope, we are in the telescope we are going to use our two lenses, either eyepiece lenses, convex lenses, which is called as eyepiece or objective. They have a very good magnification, so we can easily see our stars and moon from our Earth surface. But now instead of using lenses, we are going to use a curve mirror, which is called as a parabolic mirror. Okay, so just see. Once again, your magnification, if your telescope has a very good magnification, their formula is totally based on your eyepiece objective focal length divided by your eyepiece focal length. Okay, because it is not possible to measure distance, your image distance, object distance like that. Clear, bacha? So we are going to define our telescope magnification on the basis of which type of lenses we are going to use and what is the focal length of your lenses. Clear this? Okay. Now, so in this we are going to use, just see, in this telescope we are going to use a parabolic mirror. Just see, this is your parabolic mirror. Okay, as a objective lens. So instead of objective lens, we are going to use a parabolic mirror. This is also a kind of parabolic mirror. Or one is a elliptical mirror, M, called as a secondary mirror. So this is a parabolic and elliptical mirror. So these two mirrors they are going to use. F1 is a focal length of this first secondary mirror, and your F2 is a focal length of the first mirror. So what is the working of your mirror? We know that if your light is coming on a curved part, this is a concave part, so they are converging. So same scenario is happened over here. Just see, your light ray is coming from here. So this part is blurred. So your light, it is concave mirror, sorry, convex mirror. So this part is blurred. So your light is coming from here. So we are going to say it a imaginary, they at a focus. So their light is diverging. After they passing through this lens, you see your image up to here. This is called your eyepiece lens. So in this system, only one lens is present, which we are going to use for the vision purpose, which is called as your eye lenses or eyepiece lenses. Clear this? But baki there is a two your curve part are going to be used. Once again, they are very simple angular magnification of telescope, and their magnification power is same as your f naught by fe. Clear this? Okay, this is one type of your telescope, nothing else. Okay, let's solve this question. The diameter of moon is given. So diameter of moon is 3.5 kilometer. Okay, and your distance from the earth is 3.85 kilometer. It seems the telescope whose objective and eye lenses have a focal length 4 meter and 10 meter. So your objective or eye lenses focal length is given. Then they are going to, what is the angular diameter of image of the moon? So they are going to ask, what is the diameter of moon? Okay, so what is given? So just see your objective, that means f naught is given, which is 4. Fe is given, which is 10. Okay, so first find the magnification power. What is the magnification power? So your magnification power is equal to minus f naught by fe, which is minus 4 by, am I right? Okay, so it is given minus 4 by 10, but see student, this is meter, this is a centimeter. We need to convert 10 to the power minus 2. Not 10 to the, yeah, convert this. So you take either in centimeter or convert in a meter. So we are going to take a convert in a centimeter. So just see, it's something 10 to the power 2 here. So because 10 to the power, yeah. Why I'm going to convert in a centimeter? Because it's easy to carry a big number as compared to 0 point some kind of number. Okay, this is a reason, nothing else. You either convert in a meter also. So now see, this becomes a 10. So it becomes 100 divided by 10. 400 divided by 10. So its magnification becomes minus 4t. Clear this? Okay, now they are going to ask, they given you the diameter of moon is 3.5 and distance from the earth is 3.8. Okay, so just imagine this is your telescope, and here if you are going to see, so where your image form, your image somewhere here form, and your eyepiece lens is you are going to see from here. So they are going to say the distance from this is 3.8 into 10 to the power 5 kilometer. Okay, and your moon diameter will be is, this is a moon. So this is a moon, your diameter is something 3.5 into 10 to the power 3 kilometer. This is 10 to the power 5. So find what is what will be angular diameter of image of a moon. So this is your actual diameter of moon. That means this is your object. They are going to say what is the diameter of your image. So now tell me, what is the formula now we are going to use? Hello? Anyone? Any idea? Your object is given. That means diameter of object given. They are going to ask diameter of image. Am I right? This is a, and they also given the distance. So now tell me. Hello, students. Tell me, bacha. Not understood? Okay, I'm going to talk this. What is your alpha angle? What is your alpha angle? It's a height by d. Am I right? Am I right? What is the meaning of height? Height, that implies object. Am I right? And distances imply where is your object is present. Am I right? So it is something we can say here. Your objective length is simply 3.5 into 10 to the power 3 divided by 3.8 into 10 to the power 5. Understood? So if you are going to solve this, is something 0.009 radian. Clear this? This is your alpha. Okay. Now they are going to ask what will be your angular diameter of your image. That means they are going to ask your diameter of image, in short your image. So what is your angle, bacha? If you remember, you are going to say your magnification power is equal to beta by alpha. So from here we get beta is equal to magnification power into alpha. Am I right? Now solve this. What is your magnification power? 40 into 0.009. Solve this. You get this answer 0.0336 in radian. So after converting in a degree, you get 21 degree. Clear this? Which option is correct? Your 21 degree. Understood? They are not given you directly and ask the find alpha angle and beta angle. They given like that. You need to specify where is your alpha and what is your beta. They said, what is this said? They said that diameter of moon this and distance of the earth from this. That means they said the basic distance, which is your diameter. That means this is your object height and this is a distinct division. So we can say your alpha angle is given. Understood, bacha? Up to here. Okay, let's move further. Just see. So your answer is 21. This MP is a visual angle. So now let's say it is related with your astronomical or normal telescope. If your magnification power, your astronomical telescope is 5, focal length of your eyepiece is 4. So telescope magnification power 5, focal length of your eyepiece is 4. Find the focal length of objective lens and length of the tube when image is formed at infinity. Now solve and tell me, what is the focal length of your eyepiece? It's a very easy question. Just see. Your magnification is F not by FE. Am I right? They given magnification lens and so we need to find FE. What is your FE? Is sorry, F is given. Unit of F naught. It's minus sign. So it becomes minus of M by FE. M into FE. So it becomes your FE is also negative in sign. So it becomes your F naught will be 20. Easy? Clear this? So your magnification, sorry, focal length of your objective lens is 20 and they are going to ask the length. What is the length, bacha? Just see. If you remember, length will be FE plus F naught because this is only your image is formed at a infinity. So it becomes 20 plus 4. It's 24 centimeter. This all option, there's a 20 or 30 word is incorporated. They are forget to incorporate. So option C is correct. Clear this? Clear, Parikshit, Sudarshan, Darshan? Okay. So option C will be correct. So what we are going to talk today? We start from your aberration. Am I right? In that we are going to talk about your chromatic aberration. That means splitting of light. In that we are going to talk about the two types of chromatic aberration. One is a longitudinal and another one is a lateral. When it is a longitudinal, we are going to talk about difference between focal length. When it is a lateral, we are going to talk about difference between height. Am I right? Then we are going to talk about your introduction of your optical instrument, which is a microscope, compound microscope and telescope. Clear this? Your normal simple microscope. Simple microscope, if it is max, it become 1 plus df, and if it is mean, it's become only d by f. Similarly, if it is compound microscope, we are going to say m is equal to m naught me. Easy? And your magnification for telescope, it becomes m is equal to minus f naught by fe, and the length will be f naught plus fe. Clear up to here? So this we are going to cover in today's session.